Question 9.63 deals with half-lives. It says, if 3.2 milligrams of the radioisotope iodine-131 is administered to a patient, how much will remain in the body after 24 days, assuming that no iodine has been eliminated from the body by any other process? And it tells us to look in table 9.2 for the half-life of iodine-131. I've gone ahead and done that. And the half-life of iodine-131 from that table is 8.1 days for every half-life. So 8.1 days for half-life. Now, I want to use the formula MF is equal to, so the final mass is equal to the initial mass multiplied by a half to the power of n, where n is the number of half-lives. And this radioisotope is in the body for 24 days, and I need to figure out how many half-lives this is. And in order to determine that, I'll say my number of half-lives is going to be equal to the total amount of time in days, 24 days, divided by the conversion factor. And I will use my half-life for that. So 8.1 days per half-life. Per half-life. And you can see that days are going to cancel out, and I'll end up with the number of half-lives, which should only have two significant figures, and I get that it is in there for 3 half-lives. 3 half-lives. There we go. So that's my n. It's going to be 3.0. Therefore, I can start plugging numbers into my equation. So my final mass of iodine-131 is going to be equal to the initial mass, 3.2 milligrams, multiplied by a half to the power of the number of half-lives, which is 3.0. And when I plug that into my calculator, I get that the final mass of iodine-131 remaining after 24 days, or 3 half-lives, is equal to 0.40 milligrams. Now, another way to solve this problem, which I think is more complicated, would just be to start out with the 3.2 milligrams. And since we know that 24 days is equal to 3 half-lives, or we can divide it into 3 different times. So if we took the 3.2 and we multiplied it by a half or divided it by 2, so this would be the first half-life, I would take my calculator and say 3.2 divided by 2 gives me 1.6 milligrams. So again, that's 1 half-life, and I have to go 3 half-lives. So I do it again, and I get 0.80 milligrams. And then after the third half-life, I divide it by 2 again, and I get my final answer, which is 0.40 milligrams, which is equal to my final mass. And so you can solve these kinds of problems this way, but this method gets cumbersome once you get up to large numbers of half-lives. And that's why I think it's better to use the formula, the final mass is equal to the initial mass multiplied by 0.5 to the power of the number of half-lives.